Hey, fifth grade, let's take a quick look at how we can understand multiplying by decimals. I want to bring you back to our place value chart really quickly because this is a great way to visualize why our numbers in our base 10 system work well. Let's start out with a basic number of 1. Okay, so when I have 1, I could place this in my ones chart. I have 1, 1. Once I have 10 of those ones, I know I can trade that in for a 10. So 10 ones cannot stay in this one place. I would move my 1 over, place a 0 in my ones. I now have a group of 10 with 0 ones. Okay? Once I have 10 of those 10s, I have 100, and I can group them together into a 100. So 10 tens is actually, with 0 ones, is actually 100. Okay, you guys know this. You've worked with this for years. 10 of these hundreds becomes 1,000. 10 hundreds is actually 1,000. Okay, so noticing on our hundreds chart how every time we have a group of 10, we're moving over. So I know that 1 to 10, the value increases by times 10. When I go from 10 to 100, I had to have 10 tens to get 100, again, times 10. To get from 100 to 1,000, I had to have 10 100s times 10. So, as we move to the left on our place value chart, our value increases 10 times in each place. The same is true as I go the other way. If I were to take 1, 1, and break it into 10 equal parts, I would have 1/10. 1/10 is the same as saying dividing 1 into 10 little parts. So as I go to the right, I am actually dividing by 10, or I'm taking 1/10 of the value. If I had a 1 little tenth and I broke it up into 10 again, I would have 1/10 of that. I'm dividing by 10 again, and I would have hundredths. So as we move to the right, we are dividing by 10 or taking it by 1/10 each place we go. So let's look at something like this. If I had the number 8 times 25 hundredths, okay, we know another way to say 25 hundredths is 1/4. Because if I have 25 hundredths, that's the way I write 25 cents. It's 1/4 of a dollar, so 1/4. So instead of 8 times 25 hundredths, I could think of 8 times 1/4, and another way we say that with words would be 1/4 of 8. 1/4 of 8 is dividing that 8 into 4 equal parts, right? So I would have 2. 1/4 of 8 is 2, okay? What does that mean here? Well, what if it's not times 25 hundredths, but it's just times the whole number 25? Let's look at that on our place value chart. So 25 hundredths would be written like this on my place value chart. I have 2 tenths and 5 hundredths. How do I get this number to 25? On my place value chart, I can look and see how many times did I move to the left. Remember what we said? Every time we move to the left, we're doing times 10. So my 2 moved from tenths to ones to 10. I moved over 1, 2 columns on my place value chart. Same way with the 5. I went from hundredths to tenths to ones. I moved 2 places on the place value chart. To get from 25 hundredths to 25, I took this number times 100. Times 10 times 10. 10 tens is 100. So I can do the same problem the same way. 25 is 25 hundredths times 100, right? So if I know that 8 times 25 hundredths is the same as 1/4 of 8, which is 2. If I want to multiply 8 times 25, I can still think of that. Wait, what was 8 broken up into 4 equal parts? 2. Well, since this is 25, I will now multiply by 100. So 2 times 100 would be 200. 8 times 25 hundredths is 2. 8 times 25 is 200. Let's take a look at another problem. What if I asked you, what is 3/4 of 12? Earlier we talked about 1/4 of 8, and we knew that 1/4 meant I divide that 8 into 4 equal parts, I get one of those parts. This is 3/4. So let's do another visual really quickly. I'm just going to draw a simple box here. If I divided it into 4 equal parts, okay, and I have 12, all right, if this total box would equal 12. If I had to divide my 12 into 4 equal spaces, how much would go in each of those? So when I'm thinking of that, I'm thinking of 12 divided by 4. So let's say we have 12 pieces of gum, and we're giving it equally to 4 people, all right? So 12 divided into 4 equal parts, what times 4 is 12? Oh, 3. So 3, 3, 3, and 3. 3 plus 3 is 6, another 3 and 3 is 6. Okay, 1/4 of 12 is 3. So I need 3/4. I need 3/4. 3 of those 1/4 parts. 3 and 3 is 6, and 3 more is 9. So 3/4 of 12 is 9. All right? Didn't need my place value chart for that. But what if the problem instead was 75 times 12? Let's think about what I know about 3/4. 3/4 written as a decimal. Again, I think back to money. That makes it easy for me to think of. 3/4 of a dollar, 3/4 of a dollar. We would say 75 cents. 75 hundredths. How do I get from 3/4 of 12, 75 hundredths to 75? I move to get to 75. I have to move each digit over 2 places on my place value chart. 1, 2, 1, 2. We said each place is times 10. Times 10 times 10 is 100. So 75 hundredths times 100 is 75. I know that 75 is 75 hundredths times 100. So I could write it like this: 100 times 75 hundredths times 12. Another way to say 75 is just 75 hundredths times 100. And I'm using parentheses here. When I use parentheses, it just tells what to do first. All my symbols are multiplication, so I can very easily move these parentheses. Instead of doing this 100 times 75 hundredths to get to 75, first I'm going to think about, what is 75 hundredths times 12? That's what we just did up here, 3/4. 3/4 of 12 was 9. I could think about breaking my 12 into 4 equal parts and keeping 3 of them, which we knew would be 9. Times 100, we know that one easily in our head. So in this case, it's 900. So understanding the relationship of whole numbers and decimals by understanding we're either dividing by 10 as we move to the right on the place value chart or multiplying by 10s as we move to the left on the place value chart, we can easily do problems that look intimidating, like 75 times 12, by thinking back to what we understand about fractions and decimals. In this unit, you're also working with ratio tables. With our ratio table examples, we've been thinking about the cost of one item and then what the cost of making more would be. So in this case, let's say that making a bracelet, one bracelet costs $1.20. First, let's do times 10. Okay, so times 10, I would move one place over on the place value chart. Each digit has to move one place over. So what would it cost to make 10 of these bracelets at $1.20? It would cost $12 even. 10 times $1.20 is $12. Okay, so $12. Now, I know that to get from 1 to 10 times 10 and $1.20 times 10 would be $12. If I wanted to find out the cost of 100 bracelets, I could take another times 10, or I could think of my 1 times 100. In this case, let's just move over that times 10. 10 times 10 is 100. I'm going to move one more place on the place value chart. So in this case, 10 would now cost $120. We can still multiply decimals by 10 and 100. We can't simply put zeros on the end anymore because behind a decimal, those don't have any value anymore. But we can instead think about how those digits are moving as they increase by 10 and where that then moves our decimal to in that number.